All right, so people were asking me how to predict formulas, um, especially using the technique from the lab 4.08, the ionic compounds lab. Um, so I've included that, and I've included some other examples like writing formulas from names or yeah, writing formulas from elements in terms of covalent compounds. But I just wanted to have this on board so that when we get to Unit 5, you can take a word problem and write it out as a chemical reaction. Okay, so here we go. So for predicting formulas, so this is directly from that 4.08 lab. I mean, not actually directly, but the technique is directly from. Okay, so there are a couple of different ways to look at this. When you're looking at an ionic compound, um, and you think about, okay, so they're exchanging electrons. So we have our electron giver and we have our electron taker. Um, and so what we want the charges to equal out to is we want it to equal out to 0 total, okay? So when we're writing an ionic formula, we are looking at the simplest ratio of the two ions that will get it to a charge of 0, okay? And so you can look at this mathematically, you can do the crisscross method, whatever you want to do. And I'll show you all of those so that you have all of those techniques at your disposal. So if you're mathematically inclined and you can look at this and say, oh, well, the charges are +2 and -2, and that already equals 0. So that means I need 1 magnesium and 1 sulfate for my overall charge to equal 0. And so you would write your formula, okay? And then in the crisscross method, what you would do is, if you're like math, schmath, um, you would just take the number, the number from the charge, not the charge itself, not the plus or the minus part, but just the number of the charge, and you would bring it, oh, shoot, hang on, sorry. You would crisscross them so that you would have, you would bring those down and they would become the subscripts of your formula. So if you were looking at that one, sorry, that would be Mg. And so you would bring down that 2 from the SO4, and then it would be SO4. And when we're looking at polyatomic ions, the entire structure is stuck together. We don't separate it out. We don't take that, that subscript off or anything. And so that 2 would go on the outside of parentheses because we would need 2 of this entire sulfate because the entire sulfate has that 2 charge, okay? And so if we are thinking about ionic compounds, once you see this, you should be able to say, okay, well, we need the simplest ratio. So our ratio of magnesium to sulfate is 2 to 2, but I can simplify that to 1 to 1, and then that would give us MgSO4, okay? So that's the 2 ways that I've got in my repertoire. That doesn't mean that those are the only 2 ways in the world. I'm sure that other people have very interesting ways of doing this, okay? But those are the 2 ways that I know of. All right, so if we're looking at this one, mathematically, we need these charges to balance out and equal to 0. So if you're looking at this mathematically, you would need 2 of these charges. So that means that you would need 1 magnesium, and you would need 2 OHs in its entirety. Okay. And if you did the crisscross method, there's a 2 right here. It's going to come down here, and the 1 will come down here. And so that crisscross method will give us the same thing. I apologize for looking at a different screen from you. Okay. All right, and so I'm just going to practice with the next one. Let me see if I can move my face out of the way a little bit because it's covering up my stuff. Sorry about that. Here we go. Yay. All right, so we'll look at our next example, crisscross or math. Math, you have to think about a little bit more. It's like one of those ones that we did, and we had to keep adding to get our charges to equal 0 the other day when we were doing those puzzle pieces. Okay, And so if you look at this one and you look at this one, the greatest common factor is going to be 6, okay? So in order to get those equal to each other, they both need to equal 6. So you would need 3 of these and 2 of these, okay? Notice that our charges are going to be the opposite subscript, okay? So it would be Fe3, and that entire PO4 is together, and there's 2 of those. All right, let's see what happens with this one. So we want our charges to equal 0, and so those are equal to each other, or those cancel each other out to equal 0. So we only need 1 of this one and 1 of that one. So 1 Fe and 1 PO4. Okay. And then, oops, same here. I accidentally dried my pen. We've got plus 1 and a minus 1. Those equal 0. And so we only need 1 of each to get that. All right. So our next one is writing ionic formulas from names. So this is where unit 5 is going to come in. And so, so far we've been doing naming, but you need to be able to go in the opposite direction too, okay? So in terms of this one right here, manganese 2 hydroxide. So manganese is a transition metal. And so what we have to do in the name is we have to tell what the charge is, because remember, transition metals can transition their valence electrons. So they don't always have the same charge. That's why we have to write the charge in the name, okay? So this tells you the charge for this metal right here. And so what I like to do is I like to just write out the parts first and then figure out the charges, because sometimes it gets a little hairy if you're trying to do all of it at once. So I would write out manganese and I would write out hydroxide, okay? And so I know that hydroxide has a -1 charge. I know that manganese has a +2 charge because of this right here, okay? And so I need 2 of these to equal 0. And if I crisscross my charges, it becomes MnOH2. Okay. Sodium sulfate. Sodium looks like this. Sulfate looks like this. So sodium, I look at my periodic table. It's in group 1, so I know it has a +1 charge because it only has 1 valence electron. Sulfate, I have to look at my ion chart, and it tells me that it's a -2. So that means I need 2 of these to balance that out and equal to 0. So my formula would become Na2SO4. And you can see if I crisscross those charges, that's what would happen. Okay. Barium phosphate. Barium and phosphate. I would look at my ion chart. I know that this is a 3- and this is a 2+. From my ion chart and my periodic table, again, this is one of those like we had to do with the multiple puzzle pieces. So our greatest factor is 6. So we need 3 of these and 2 of these. And notice those charges are going to become the other one's subscript. So that Ba3 and that PO4 goes in parentheses because we need 2 of the entire thing. So 2 of those. Zinc chloride. I write out my zinc, my chloride. I know from my information that zinc is one of those metals that are in the transition metal part, but technically they only have a native charge of +2 all the time, okay? And then my chlorine is a -1, so I need 2 of these. So my formula becomes ZnCl2. That equals 0. All right. And our last example for ions, here it is again, okay? Transition metal. Just think of that as that's what's telling us the transition metal, okay? So it looks like this: CO, and then CO3 is our carbonate. Cobalt has a 3+ charge. Our carbonate has a -2 charge. So you can either crisscross, or you know that they equal 6. So you need 2 of these and 3 of these. So it would look like CO2, CO3. All right. And so I am going